Hello everybody and welcome to our lessons in electronics. In this video I will explain to you how to measure inductance using a capacitor and the resonance frequency of the LC circuit. So there are a few other ways on the internet that show how to measure inductance. One of the ways that is shown is to determine the phase and the amplitude of the signals on the input and the output, basically connecting an inductor with a resistor and then measuring this signal here across the inductor and hooking this up to a function generator. But this method is not very exact. A much better method is to use the resonance of the LC circuit. And by the way, for this you will need a function generator that generates a sinusoidal wave. You need to be able to adjust the frequency of this wave, and you also need an oscilloscope so that you can measure the response of this circuit. So we'll use a circuit like this. We have our inductor. This is the inductor under test. This is the inductor we're going to measure. And we also hook up a capacitor across the inductor. And choose this capacitor. Use a small ceramic capacitor with small series resistance, and preferably use a capacitor that is 1% precision so that you get more precise results, because we're going to be using the value of this capacitor to calculate the inductance. So we need to have a capacitor that is exact. For this example, I will use a 100 nanofarad capacitor. And this is equal to 100 to the power of -9 farads. And inductor is our L, and we will also use a resistor here. It doesn't really matter what resistor this is. You can use like, let's say we use a 1K. And we'll hook this one up to the function generator. So here we will feed a sinusoidal wave, and we'll adjust the frequency of this wave. And here we'll connect the scope. So this will go into the scope, and this will go into the function generator. And this will go to the ground, where both of these are connected. So what we want to do now is find the frequency at which the amplitude of this signal is the highest. So when we adjust the input signal, we will see that the amplitude will grow. So first you might see something like this, and then as you increase the frequency you will see something like this, and then you increase it some more, and it will grow even more, and then eventually it will start decreasing again. So you want to find this corner frequency where it is the highest amplitude, and where you can easily see that the signal is decreasing in both directions, if you increase the frequency, if you decrease the frequency. So now you've found this peak, the resonant peak of the LC circuit, and this peak is located at some frequency. We call this f, let's call this just f hertz, because we'll measure this frequency in hertz. Now the f hertz, the formula for L hertz or f hertz is 1 over 2 times p times square root of LC, where L is in henries and C is in farads. So now that we know our f hertz, what we need to do is just solve for our L. And our L becomes, let's see, our L becomes 1 over f hertz to p to the power of 2 divided by C. So now if we know the capacitance, if we measured the frequency for the resonance, and if we And if we have this formula, we can easily calculate the inductance. So let's say we use the values that we have here, and our frequency ends up being at 100, let's say 100 kilohertz. So now we can just plug this in. So we get L equals 1 over 100 to P to the power of 2 divided by 100 to the power of minus 9. And I just need to check what this is gonna equal. And by the way, this 100 here, it's actually supposed to be 100,000. So it's 100 times 10 to the power of 1,000, because it's 100 kilohertz. So this equals 25 microhenry. So now I measured the inductance of this coil. And this is useful when using coils that you maybe create yourself, or when you don't know the inductance. And it's an easy way, provided that you just have a function generator and an oscilloscope, which are two of the probably most essential tools that you should have if you're doing electronics work. So thank you for watching. I hope you learned something, and I'll see you in another video.